This lesson is from Comparing and Scaling Problem 4.1. This is the information given to my students prior to working on the problem. This particular problem is really a review of everything that they've done so far, but it's put into the context of proportions, which is defined as an equation that shows that two ratios are equal. The situation we'll look at on the paper here: at the Sherwood Animal Shelter there are 34 dogs and 4 cats. At this ratio or rate, how many dogs would you predict if there were 11 cats? In this particular lesson, this is the first time they're writing proportions, so we're going to look at 4 different ways that you could write the proportion. The first method is in the way that it is given here, of a ratio of 34 dogs to 4 cats. Now, since we're setting this equal to something, writing the ratio in a way that looks like a fraction is the way to do this. So we're saying that that ratio is equal to the new ratio of dogs to cats. And we know that there are 11 cats, so we're going to put that down at the bottom as this one is. And the number of dogs is what we're looking for. In the textbook, they use an X. I'm just using a box here to identify where we need our number. In the second method, similar to the lesson yesterday, they're looking at the reverse of these two, just flip-flopping the positions. So 4 cats to 34 dogs. And that ratio is equal to the 11 cats over that unknown number of dogs. The third method is more of a new one, and that's looking at the ratio of the cats and the ratio of the dogs, and those two ratios would be equal. So initially there are 4 cats. What we're trying to investigate is up to 11 cats, and that ratio is equal to the ratio of the number of dogs. So the initial number of dogs is 34, and the number of dogs that we're trying to find is our unknown. So the ratio of the cats is equal to the ratio of the dogs. And the fourth method again is simply reversing those two. So the new number of cats to the previous number of cats, and the new number of dogs, which is our unknown, to the original number of dogs. Now, in each one of these, the known values are together. So these two are representing our known values. And again, they're on the same side, but in different positions. On the the third and fourth ones, the known values are found left and right. And on this one, they are found at the bottom. So I also want to show one that does not work. So if we were trying to make method number 5, and we started with the 4 cats and the 11 cats in one ratio, and we were saying that was equal to the number of dogs we need to find over the 34 dogs. And then we try to label what the known values were. The 4 cats was an initial known value, as well as the 34. And because those are in different locations, they're not in a consistent left to right or up and down, this method actually would produce incorrect results. So that is one not to use. There has to be a pattern to how the numbers are placed there. Putting down the labeling is very important, and you can even add on there, this is what we know, this is what we need to find. So I'm going to use number 4 here to show 2 different ways that we could solve this problem. The first way is, again, similar how we were finding unit rates from the previous lesson. if we need to know how to scale the 4 cats to the 34 dogs. How many times more dogs are there than cats is the question that we're asking. The way to find that, the scale value, is found by taking the 34 dogs, dividing it by the 4 cats. That will tell us what would be multiplied by the 4 to get 34. So in the calculator, I'm going to do 34 divided by 4, and it's 8.5. So that tells us there's 8.5 times more dogs than there are cats. If the ratio is the same, then there should also be 8.5 times more dogs than this number of cats. So we're going to multiply the 8.5 times the number of cats. Here's my 8.5 times the 11 cats, and that's 93.5 dogs. Now, because we cannot have partial dogs, it would be appropriate to round this up to the nearest whole dog, and then we would say there's about 94 dogs when there are 11 cats. Now, looking at this in a different way, setting it up the same way, this time we can look at the ratio of the cats. The cats increased from 4 up to 11. We need to know how many times more cats there are in the unknown values. So scaling 4 up to 11 would be a process of 11 divided by 4. 11 divided by 4. That tells us that there are 2.75 more cats in the new ratio than there were in the original ratio. So the number of dogs also needs to increase by that same factor of 2.75. So 34 dogs, 2.75 times. Here's the 2.75 times the 34 dogs, and again we see that 39.4 or 5 dogs, which supports our original conclusion here. There's about 94 dogs when there are 11 cats.